Okay, so syllabus is first. I'll discuss about that basic properties of nucleus. Okay, then we'll discuss about that important properties, that is binding energy. Then we'll go to properties of nuclear force. Okay, then we'll go to various models. So first, I'm interested to talk about that Fermi gas model. Fermi gas model. Okay, then we'll go to liquid drop model. Further, I'll go to cell model. Okay, then we'll go to collective model. Okay, then we'll go to radioactivity. Okay, then we'll go to deuteron problem. Okay, then we'll go to nuclear reaction. Okay, at the end, we'll discuss about nuclear fission and nuclear fusion. ओके, आप लोगों को दिख रहा है सब?
यस सर।
हाँ, अब इसमें जैसे जो जैम वाले हैं, जैम के लिए बेसिक प्रॉपर्टीज ऑफ न्यूक्लियर सिलेबस में है, बाइंडिंग एनर्जी है, प्रॉपर्टीज ऑफ न्यूक्लियर फोर्स है, फर्मी गैस मॉडल है, लिक्विड ड्रॉप मॉडल का सम पोर्शन है, बट कुछ पोर्शन लिक्विड ड्रॉप मॉडल का नहीं होगा, सेल मॉडल तो नहीं है जैम में, कलेक्टिव मॉडल नहीं है, रेडियो एक्टिविटी है, तो जैम के लिए अलग हो जाएगा। ये सारे हम साथ में करेंगे, बेसिक प्रॉपर्टीज ऑफ न्यूक्लियस, बाइंडिंग एनर्जी, प्रॉपर्टीज ऑफ न्यूक्लियर फोर्स, फर्मी गैस मॉडल, लिक्विड ड्रॉप मॉडल, देन देयर विल बी सेपरेट। For JAM, that syllabus is radioactivity is there. Only this part is for JAM, and this is all about your NET syllabus, NET and GATE. Okay, but जो लोग JEST देना चाहेंगे उसको मैं रिक्वेस्ट करूंगा कि सेल मॉडल तक वो रुके, ठीक है, क्योंकि सेल मॉडल आपका यस।
So the left syllabus which you have not ticked, all is for NET and GATE.
यस,
Okay, sir.
यस, ओके। तो जाम का जो बच्चे हैं वो 5 तक रहेंगे, फिर उनके लिए अलग से रेडियो एक्टिविटी पढ़ाया जाएगा, ठीक है, सेपरेटली। और जो जेस्ट देना चाहेंगे उसको सेल मॉडल भी पढ़ना पड़ेगा साथ में, ठीक है। आप लोगों ने लिख लिया, चला इरेज?
Yes, sir.
Okay. So today will be basic about that nuclear physics. So I know I think every people knows about it. Okay. So जो लोग जानते हो उसके लिए भी अच्छा है, उसका रिवाइज हो जाएंगे, और जो नहीं जानते हैं उनके लिए क्या हो जाएंगे, डिटेल स्टडी हो जाएंगे, ठीक है। Okay. So first we'll write from the beginning. You know the symbol of nucleus is represented as, आपका सिंबल है न्यूक्लियस का, कोई भी न्यूक्लियस का, ZA. Z क्या है? So X is nucleus, its atomic number is Z, mass number is A. So Z is known as atomic number, A is known as mass number. Mass number. So this is actually number. This is not mass. Okay. So A is nothing but number of neutron plus number of proton. So Z means atomic number. Atomic number means number of proton present in that nucleus. So from here you can write that number of neutron is nothing but mass number minus atomic number. So N is represented here the neutron number, and that is nothing but mass number minus atomic number. So this is known as neutron number. Okay. So in a nucleus, there will be Z number of proton and number of neutron will be A minus Z. If you count whole atom, so there will be Z number of electron also. The charge of electron is negative and exactly same as the charge of proton. So if you take atom, so atom will be neutral because there will be Z number of electron will be there. So if you take atom, it will be neutral. Okay. So let us denote that MP. MP is the mass of a proton, and Mn is the mass of a
Neutron.
very good neutron. And also let us assume Me is the mass of a
Electron.
Okay. So you know the mass of proton is almost close to the mass of neutron. Okay. So how much is the mass of that proton? Anyone? How much is the mass of the? Yes, can you write in MEV? MEV unit?
Like 938.
Exactly. Very good. So it will be around 938. Okay. Around 938 mega electron volt per c square. So mass of proton and mass of neutron is almost same. Not exactly, but almost close to same. But on the other hand, the mass of electron is very, very small as compared to mass of proton. Also, you can say that mass of electron is much, much smaller as compared to the mass of a neutron. And you know that mass of electron is how much? Mass of proton time on 836. So you can understand how much small it is as compared to mass of a proton. Is it clear to all? Is it clear? Okay. So this is all about some basic fundamental about that nucleus. Now we'll go to an important model or important experiment. Every people now learn about this. That is Rutherford experiment. Okay. So we'll go to Rutherford experiment. Rutherford experiment. So in Rutherford, what he has taken, and that Rutherford scattering also you can say, Rutherford scattering, better it will be Rutherford scattering. So that that phenomena came in 1910. So what Rutherford has done, he has taken on radioactive source, and that is basically alpha emitter. Its name is radium. Its atomic number is 88, and its mass number is 226. Okay, and he kept this radioactive source or alpha emitter. So this source basically emit alpha particle. So he kept this source inside lead box, and he there is a hole inside in the lead box. So there is a emission of alpha particle. What is alpha particle actually?
Helium.
Helium 2 plus.
Helium 2 plus. Very good. So there is a radioactive source, name is radium. Its atomic number is 88, mass number is 226. It's emitting alpha particle, and he has taken on very thin gold sheet. He has taken a very thin gold sheet. So this is your gold sheet. So gold symbol is AU. So this is gold sheet. Okay. So when that alpha particle striking this gold foil or gold sheet, also it is important to mention here that gold sheet is so thin, and why he has taken that thin gold sheet. So his plan is that each alpha particle can only interact with a single gold nucleus. So that's why he has taken very thin gold foil. So when that alpha particle striking this gold sheet, what he has observed also, he has kept this gold sheet inside a fluorescent screen. This is your fluorescent screen. So what he has observed that most of the alpha particle after striking this gold foil, their path is undeviated. So they are moving as before. Okay. But very few alpha particle are scattered at small angle. So that angle is small, that is theta. Theta is nothing but around 30 degrees. So few alpha particle is scattering at very small angle. Okay, and few alpha particle is scattering at large angle, and also he noticed that one alpha particle out of 20,000 is actually backscattered. Backscattered means what? What is going, and is after scattering it is coming in opposite direction. So what he noticed, there are many alpha particles striking this gold foil, but most of them are their path is undeviated. They are moving as a straight line. Only few alpha particle is scattering at very small angle, and that angle is around 30 degrees. Very few alpha particle scattering at large angle, and only one out of 20,000 alpha particle is actually backscattered. Then he started thinking that, shall I erase? Shall I erase?
Yes, sir.
Yes, sir.
Then he started thinking that most of the mass and most of the charge is concentrated at the center. most of the mass and most of the charge is concentrated at the center, and he has given this name. So most of the charge and mass is concentrated at the center, and he has given this name of the center is nuclei. So he has given that first name nuclei. Okay. So then what is happening if the positive charge is concentrated at the center, and let us assume this is your atom. So what is actually happening? Suppose a alpha particle is going. So alpha particle is also positively charged. So when it is going at far away from that nucleus, so there will be not that much Coulomb interaction. So it will be going as it is, or you can say its path will be undeviated. But if the alpha particle is coming very close or close to that nucleus, so there will be strong Coulomb interaction. So due to this Coulomb interaction, there will be scattering of this alpha particle. So this angle, if suppose this is θ1, if alpha particle is coming more close to that nucleus, then what will happen? Due to more Coulomb interaction or Coulomb repulsion, there will be much scattering, or you can say that scattering will be angle will be large. So let us assume this is θ2. So since this is close, so in that case θ2 will be much or greater than θ1. So what he assumed that since most of the particles are undeviated, so inside atom most of the part is empty, and the charge and mass of that nucleus is mass of that atom is concentrated at the center, and he has given that first time that name, that is nuclei. But he was not aware about that there is exist of neutrinos. He don't know that a neutron is exist inside nucleus, but he has given that prediction that most of the mass and charge will be concentrated at the center, and that name is nuclei. Okay. So later we'll discuss also. Later he found that the size of this nucleus is of the order of 10 to the power minus 15 meter. And also he noticed the size of the atom is of the order of angstrom. Okay, of the order of angstrom. Okay, you know that angstrom is 10 to the power minus 10 meter. Okay. And also he said that electron is revolving around that nucleus, and that the path of that nucleus will be stable, or path of the electron will be stable, because there is a Coulomb interaction between the positive charge of that nucleus and negative charge of the electron. So he has given that that prediction that mass and charge will be concentrated, electron will be revolved around this nucleus, but he was not aware about that the existence of neutron. Is it clear?
Yes, sir.
Yes, sir.
Any doubt?
Sir,
Hmm.
sir, why we not consider the electron scattering? I mean, sir, how, सर कैसे हम आइडेंटिफाई कर रहे हैं कि ये न्यूक्लियस प्रोटॉन से स्कैटर हो रहा है और इलेक्ट्रॉन से स्कैटर हो रहा है?
Yes, that you see, that's why that is you have taken gold for gold, right? Its charge is so high, 79, right? And on if you take one electron, say scattering will be less, because that force is proportional to Q1, Q2. Inside that nucleus, you have a large amount of positive charge. Is it clear?
Yes, sir.
Okay. Is it clear? Also, the important thing is he has derived two relation, that is expression for impact parameter, and also the angular scattering distribution. So angular scattering distribution means number of scattered particle at some scattering angle theta. So he has derived this expression based on two assumptions. Please write that assumption. Please write. First assumption is the alpha particle and target nucleus means gold nucleus. The alpha particle and target nucleus are point charge.
Sir, nucleus?
The alpha particle and target nucleus both are point charge. Okay.
Okay, sir.
Next is the mass of target nucleus. The mass of target nucleus is very high. The mass of target nucleus is very high. So whenever there is an interaction between alpha particle and target nucleus, due to the heavy mass of the target nucleus, after scattering, there will be no shift in the position of target nucleus. So first assumption is the alpha particle and target nucleus both are point charge. Second is the mass of target nucleus is very heavy. So there is no interaction, there is no shift in position of target nucleus after the interaction between alpha particle and target nucleus. Okay.
Can you repeat after shifting?
So the mass of the target nucleus is very large. So there will be no shift in the position of alpha particle after interaction between there will be no shift in the position of target nucleus after interaction between alpha particle and target nucleus. So it is happening like that. Suppose this is your target nucleus. So alpha particle is coming. So there will be Coulomb interaction, right? So after Coulomb interaction, that alpha particle will be scattered, but there will be no shift in the position of target nucleus because it's so heavy. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Okay, very good. Yeah, yes. Okay, so let us define that impact parameter, because ultimately his goal is to derive the expression for impact parameter and the angular scattering, the distribution or number of particles scattered at some angle theta. So let us first define that impact parameter. आप लोगों को समझ में आ रहा है?
Yes, sir. हाँ, sir.
कोई
Yes,
doubt?
sir.
Okay, very good. So that impact parameter, it is basically denoted by small v. So please write the definition first, then I'll proceed. I'll explain that. The impact parameter is the minimum distance at which alpha particle would approach the nucleus if there were no force between them. It is the minimum distance at which alpha particle would approach the nucleus or target nucleus if there were no force between them. So what does it mean? Suppose you have, this is your nucleus or gold nucleus.
Excuse me, sir.
Yes.
So last वाली line बोल देना एक बार.
हाँ, yes, yes. So if there were no force between them. इतना ही बोलना है या आगे भी बोलना है आपको?
नहीं सर, इतना ही है. Thank you.
Alpha particle.
Yeah, minimum distance at which alpha particle would approach the nucleus if there were no force between them. So इसको समझो आप, फिर क्लियर हो जाएगा. सपोज मान लो आपका टारगेट न्यूक्लियस है और गोल्ड न्यूक्लियस है. सपोज मान लो एक आपका अल्फा पार्टिकल जा रहा है. अब नो फोर्स बिटवीन देम में मतलब क्या है? ऐसे स्ट्रेट लाइन में चले जाएंगे वो, है ना? तो मिनिमम डिस्टेंस कितना हो जाएगा? यहां से जो ये डिस्टेंस है, यही तो है ना?
Yes, sir.
इफ लास्ट वाला जो सेंटेंस है वो देखो, इफ देयर आर नो फोर्स बिटवीन देम. सो अगर दोनों के बीच में फोर्स नहीं है तो क्या है? अल्फा पार्टिकल जो आपका जा रहा है वैसे अनडिवाइडेड चले, ऐसे चले जाएंगे स्ट्रेट लाइन में. तो मिनिमम डिस्टेंस कब होगा? जब ये इस क्लोज में आ जाएंगे. तो ये जो डिस्टेंस है इसको बोलते हैं आपका इम्पैक्ट पैरामीटर, और जो आपका लाइन ऑफ एक्शन ऑफ न्यूक्लियस है ये है, मतलब towards the center, that line. So impact parameter is defined in other words also. Impact parameter is nothing but the perpendicular distance between the line of action of alpha particle nucleus and the line of action of alpha particle. So we can write also that that impact parameter is nothing but the perpendicular distance between line of action of nucleus and line of action of alpha particle. Is it clear?
Yes, sir.
Next is scattering angle. Next is scattering angle. It is basically denoted by theta. So suppose you have, again I am drawing same nucleus, that is your target nucleus. Okay. So suppose an alpha particle is coming. So this alpha particle will be scattered due to that Coulomb interaction, because Coulomb force is acting in this direction. So that alpha particle will be scattered. Right.
Yes, sir.
So if we extrapolate that incident line, suppose this is alpha particle, so you extrapolate that line, it will be like this. And if you plot that asymptotic line that is parallel to your that direction of scattering, then that angle will be the scattering angle. So this is your direction of incident alpha particles. So it will be scattered at some angle due to that Coulomb interaction, and that scattering is obvious. Angle will be, that angle will be large if that particle is close to that nucleus. If it is at large distance, that angle will be small. It can be 0 also, but some arbitrary direction or some distance, that let us assume that scattering angle is theta. Then scattering angle, how we will define? So if you extrapolate that line of incident particle, so it will be like that. And if you draw a asymptotic line that is parallel to that direction of scattering, then please write that scattering angle definition. The scattering angle is defined as the angle between asymptotic direction of incident alpha particle and asymptotic line of departed alpha particle.
Sir, can you repeat it?
Yes. The angle between asymptotic direction of incident alpha particle and asymptotic line of departed alpha particle. So this line. Okay.
Sir, last में क्या था? Asymptotic line of
Departed means ऐसे incident हुआ था, after interaction it is departed, right? Departed.
Thank you, sir.
Welcome. Okay. Okay. So based on this two assumptions that we have discussed, he has derived an important relation between impact parameter and scattering angle that we have defined just now. That but the significance of this derivation is so important. So what he has observed after that assumption and basic classical theory, he has derived that relation that B is nothing but impact parameter, and what he got, B is nothing but Z E square by 4 pi epsilon naught K alpha cot theta by 2. So here Z is the atomic number of target nuclei. Target nuclei means gold. E is the electronic charge. Theta, you know, scattering angle that we have defined. Epsilon naught, you know. K alpha means the kinetic energy of incident alpha particle. So this is the expression he has observed after this assumption, or he has derived this expression. Now there is a relation between impact parameter and theta. Now can you tell me if the B is large, then what will happen to theta?
0.
So upwards means B is large, or no, not that much large, somehow it's large. So if B is increasing, obviously theta will
Theta is
be
increasing.
decreasing.
Okay, sir.
Yes, obvious. You see, suppose you have that nucleus. Now if B is, you are decreasing that B you are decreasing means, or increasing, if you are increasing that B, suppose you are taking large B, then there will be small Coulomb interaction, right? If that small Coulomb interaction is there, then scattering angle will be small. Okay, so this is your B. Now if you are bringing that B small, or if that alpha particle is very close to that nucleus, then angle will be how much? Large, right?
Large.
So yes, so you can clearly see if B is small, it means that alpha particle is very close to that nucleus. If B is large, then alpha particle is far away from nucleus. If it is far away from nucleus, obviously that angle of scattering will be small. Okay, is it clear?
Okay,
Yes.
sir.
Here B is minimum distance.
No, I'll come to every case. What I'm saying, if you increase that B, theta will be decreased, and that is obvious from this figure itself.
No, sir, we can say that B is the minimum distance.
No, I'll come at minimum distance also. Minimum distance, when it will be minimum distance? When it will be, I mean, when B will be smaller than the radius of nucleus, then you can say it is minimum distance. So there are many possibilities, right? So this is your nucleus. If that alpha particle is coming close to that nucleus, I mean that in that case, you see impact parameter is smaller as compared to the radius of nucleus. So at that situation, what will happen, that I will discuss also. Now I am taking some arbitrary point, okay, and that is large as compared to the size of nucleus. मतलब क्या है कि आपका न्यूक्लियस से दूर है, तो फिर क्या होगा, अगर b बढ़ाते जाओगे तो थीटा कम होते जाएगा, b कम हो जाएगा, फिर आपका थीटा बढ़ेगा. इतना क्लियर है क्या नहीं?
Yes, sir.
Yes, sir.
किसको क्लियर नहीं है? किसको क्लियर नहीं है अभी? और यहाँ पे आपको ये इस एक्सप्रेशन से भी आपको मिल जाएगा, b इज प्रोपोर्शनल टू कॉट थीटा, राइट? अगर थीटा आपका कम हो जाएगा, b बढ़ेगा, बिकॉज कॉट थीटा इज नथिंग बट कॉस थीटा बाय साइन थीटा. इफ थीटा इज स्मॉल, cos theta is small, it means what happened? Cos theta will be increased, sin theta will be decreased, but sin theta is in denominator, so obviously this factor will increase, okay, when theta is small, and of course b will increase because b is proportional to cot theta. At small theta, cot theta will be large, so b will be large. So from this equation I am saying that, okay, that's why he derived, and that's why that expression has great significance. Again, from this equation itself, you can say if b is, you are decreasing b, obviously theta will be increasing. And from here I am deriving, writing that, and I have given that pictorial form also. When if you are bringing that alpha particle close to that nucleus, obviously scattering angle will be large. Also, yes, what happened? Okay, now can you tell me, when B is close to the radius, R means radius of nucleus, then what will happen?
And scattering angle will be very
By 2.
At this case, that theta will be, or scattering angle will be very large.
Very large.
Okay. Now if B is much greater than the radius of nucleus, मतलब बहुत दूर है, न्यूक्लियस ए है और आपका अल्फा पार्टिकल बहुत दूर है, तो फिर क्या हो जाएगा यहाँ पे?
very small.
Theta tends to 0. Theta tends to 0. Next case, if B is smaller than the radius of nucleus, then what will happen?
Theta will
Suppose if this is your
theta will
nucleus,
increase.
not
Theta will
increasing,
increase.
it will be
scatter backwards.
exactly whatever it is going, it will scatter back. So scattered back means theta will be 180. Can you please mute your mic? This is not a proper way.
Neha Sharma.
Is it clear?
Yes, sir. It's
Yes,
clear.
sir.
किसी को कोई डाउट इसमें? सारे चीज यहीं से आपका हो जाएगा, है ना? B proportional to cot theta by 2. So there is a relation between impact parameter and scattering angle. Okay? Is it clear? Also, he has given another that expression or derive another expression that is angular. Shall I raise?
Yes, sir.
So here's derive also angular scattering distribution and it's basically denoted by n of theta. So n of theta means angular scattering means distribution means the number of scattered particle at some angle theta, and what he has observed that number of scattered particle at some angle theta is depends on ni. Ni means total number of incident alpha particle. Then small n means atomic density of gold foil. T means thickness of gold foil. Z square means atomic number of gold. E to the power 4 that you know, divided by 8 pi epsilon naught square epsilon naught square r square k alpha square sine to the power 4 theta by 2. So Ni is the total number of incident alpha particle, N is the atomic density of gold foil, T is the thickness of gold foil, Z is the atomic number of gold, 8 pi epsilon naught you know that is constant, I'll come, K alpha is the kinetic energy of incident alpha particle, sine to the power 4 theta by 2. Now what is R? R means,
Sir, it is
yes,
e to the power 4.
yes, e to the power 4.
Okay, sir.
So this is T.
Sorry,
So after N.
your voice is not clear. Can you please tell me?
So what is this after N? Sir, N के बाद क्या लिखा है?
T means the thickness of gold foil.
Okay, sir. And sir, N?
Small n means atomic density of gold foil. It means number of atom present in gold foil per unit volume. Is it clear?
Yes, sir. Thank you, sir.
Welcome. Then what is R? R means you have gold foil, right? And you have fluorescent skin. Okay. R is the separation between gold foil and that screen. That is your R. So he derived, but he was very much interested about that how that number of scattered particle is varied with theta. So what he observed that scattering distribution is inversely proportional to sine to the power 4 theta by 2. Okay.
Excuse me, sir.
Yes.
So can you repeat what is the R?
R is the separation between gold sheet and the screen. That fluorescent screen he has used, na? That separation. Is it clear? Or shall I repeat?
Sir, once again, please.
You have, this is your gold foil, right?
Right, sir.
Around it you have on fluorescent screen, right?
Yes, sir.
So if you take that distance from the center to that
Okay,
distance.
sir, okay, sir. Okay, sir. Okay, I can understand.
Yes. Okay. Now,
Sir,
yes.
sir, is there any difference between scattering and angular scattering?
Angular yes, actually angular scattering, whenever that scattering is happening, scattering is basically happening at some angle, right? So angular scattering means you can directly say that is he is trying to say about that angular scattering. Okay, scattering means like that particle is going it is scattered some angle, right? Or it can say that path is deviated from its original path.
Okay, sir.
Yes. Now
And-
we'll discuss about distance of closest approach.
Excuse me, sir.
Yes.
Sir, the projection screen is like a spherical type of shape, covering that gold foil.
Yes, yes, yes.
Okay, then R value is counting from center of the gold foil to the perpendicular distance, right?
Exactly.
Okay. Okay.
Okay. Yes, yes. Now we'll discuss about that distance of closest approach.
Hello, sir. What is NI?
NI. NI is the total number of incident alpha particle.
Okay, sir.
Shall I erase? Shall I
Yes,
erase?
sir.
Yes, sir.
Yes, sir.
Now we'll discuss about that distance of closest approach. आप लोगों को समझ में आ रहा है? किसी को कोई डाउट? Are you enjoying
समझ आ रहा
class?
सर.
Yes,
sir.
sir.
Okay.
Yes.
Okay, very good. Now we'll discuss about that distance of closest approach. Okay. And let us give that symbol is X. So suppose you have, this is your gold foil. Okay. This is your nucleus. For the sake of the time, let us assume only nucleus. Okay, only I have taken that gold nucleus. So suppose this is your alpha particle. Alpha particle is kinetic energy is K alpha. And it is approaching towards gold nucleus. Okay. Then what will happen? It will go close to that nucleus, right? Then what will happen?
It will go to a certain distance and then come back.
So it will go. Okay. Now in that case, that B is less than R. So what will happen? It will go close to that nucleus, right?
Yes, sir.
Then it will again come back. Why it will come back?
Coulombic repulsion.
Exactly. So whatever, see here you have kinetic energy. Whenever it is coming close to that nucleus, its kinetic energy is basically converted to Coulombic potential energy, right? So at very close, the Coulombic potential energy means there is a Coulombic repulsion, and if there is a repulsion, you will have some Coulombic potential energy also, because you know that potential energy or Coulombic potential energy is how much? 1 by 4 pi epsilon naught Q1 Q2 by R. But there will be Coulombic repulsion. So whenever it is coming close to that nucleus, its speed will be decreasing, and it is when it is very close, then speed will be 0. Then due to that speed 0 and due to the presence of Coulombic repulsion, it will reflect back. Is it clear? So when it reaches very close, at this point that Coulombic repulsion will be dominated and speed will be 0. That time there is exist of Coulombic repulsion, and due to this Coulombic repulsion, it will reflect back.
सर स्पीड 0 क्यों होगी?
स्पीड इसीलिए 0 हो जाएगी क्योंकि यहाँ पे आपका क्या है? पॉजिटिव चार्ज है ना. यहाँ पे आपका क्या है? ये गोल्ड न्यूक्लियस है, यहाँ पे पॉजिटिव चार्ज है. अब ये आपका जो अल्फा पार्टिकल है ये भी पॉजिटिव चार्ज है. तो जैसे जैसे क्लोज आ जाएंगे, फोर्स क्या होता है? कूलम्बिक फोर्स 1 बाय प्रोपोर्शनल टू आर स्क्वायर. कूलम्बिक फोर्स 1 बाय प्रोपोर्शनल टू आर स्क्वायर है ना. आर क्या है? सेपरेशन है. जैसे जैसे वो क्लोज आ जाएंगे अल्फा पार्टिकल आपका न्यूक्लियस की, आर क्या हो जाएंगे? बढ़ते जाएंगे. सो कूलम्बिक फोर्स क्या हो जाएंगे? बढ़ेंगे. और यहाँ पे कूलम्बिक फोर्स क्या है? रिपल्सिव इन नेचर. तो जब वेरी क्लोज आ जाएंगे तो कूलम्बिक फोर्स तो बहुत ज्यादा हो जाएगा. इफ कूलम्बिक फोर्स इज वेरी लार्ज देन व्हाट विल हैपन? इधर आपका क्या था? पार्टिकल का स्पीड था, और ऑपोजिटली आपका क्या कम कर रहे हैं? फोर्स कम कर रहे हैं, है ना. So due to this, its speed will be rapidly decreasing. When it will come close towards that nucleus, its speed will be decreasing. क्यों डिक्रीज होगा? क्योंकि यहाँ पे इसका पॉजिटिव चार्ज के कारण इस अल्फा पार्टिकल को क्या कर रहे हो? ऑपोजिटली फोर्स दे रहा है. इज इट क्लियर?
Yes.
Yes, sir.
Sir.
तो यस
सर अल्फा पार्टिकल का तो चार्ज पॉजिटिव है,
यस
तो सर वो जब सर एटम का अंदर मतलब वैलेंस शेल का अंदर जब जाएगा तो इलेक्ट्रॉन का तो सेम कूलम्बिक अट्रैक्शन है.
सेम कूलम्ब, यस कूलम्ब का अट्रैक्शन है. यस
सर वो सर क्यों उसको इफेक्ट नहीं करेगा?
इसीलिए इफेक्ट नहीं करेगा क्योंकि इसका स्पीड बहुत ज्यादा है. स्पीड इसका 10⁷ मीटर पर सेकंड है, बहुत ज्यादा स्पीड है, इसीलिए इफेक्ट नहीं पड़ेगा. और
हाँ
यस
सर, बट उसके अंदर भी तो सेम इलेक्ट्रॉन है एंड उसका सेम कूलम्बिक.
exactly, again I am saying when you are taking that gold nucleus, it has large atomic number, it means it will have large number of protons. So यहाँ पे आपका क्या है 79 number of protons एक small जगह पे है ना, समझ रहे हो? तो इसीलिए यहाँ पे इसके लिए आपका जो फोर्स है ये डोमिनेंट होगा. और एक इलेक्ट्रॉन अगर इसमें है आपका ऑर्बिट में, तो क्या है एक इलेक्ट्रॉन का फोर्स ज्यादा होगा या सारे न्यूक्लियस में इतना सारे प्रोटॉन्स है उसका फोर्स ज्यादा होगा? ऑब्वियसली उसका ज्यादा होगा. एक इलेक्ट्रॉन का फोर्स कितना होगा? बहुत स्मॉल होगा. एंड ऑल्सो इट इज नॉट दैट इलेक्ट्रॉन इज नॉट फिक्स्ड एट पर्टिकुलर पोजीशन, इट इज ऑलवेज रिवॉल्विंग, राइट?
यस सर. सर तो ये कितना तक जाएगा, मतलब
हाँ यहाँ पे वो फोर्स इग्नोरेबल है. ये क्या होगा, एटम इसका स्पीड बहुत ज्यादा है तो एटम के अंदर जा सकते हैं, बट it will reach some position. After that, due to that Coulomb repulsion or domination of Coulomb repulsion, it will reflect back. But ये जो है आपका जो अल्फा पार्टिकल, it will never touch that nucleus. It cannot touch. यही जो डिस्टेंस है जहां पे इसका स्पीड 0 हो गया, इसी को बोलते हैं डिस्टेंस ऑफ क्लोजेस्ट अप्रोच. कैन यू कैलकुलेट दैट डिस्टेंस ऑफ क्लोजेस्ट अप्रोच नाउ? एनीवन? जल्दी कीजिए क्योंकि ऑप्टिमाइज करना है, आगे जाना है थोड़ा, है ना? जल्दी कीजिए. हाउ मच इट विल बी? सो इनिशियली आपका एनर्जी कंजर्व होगा, है ना? सो इनिशियली इट हैज एनर्जी हाउ मच? अल्फा पार्टिकल का कितना एनर्जी था? हाफ m. लेट अस एज्यूम दैट मास ऑफ अल्फा पार्टिकल इज m अल्फा v अल्फा स्क्वायर. It should be equals to, and it should be converted into Coulombic potential energy, and that potential energy is how much? So 1/4 pi epsilon naught into charge of nuclear charge of gold. It is how much? 79 e into the charge of alpha particle, that is how much? Twice e divided by, let us assume that distance of closest approach is x. Okay, so you know that mass of alpha particle, right? Mass of alpha particle is how much? 4 times mass of proton. Mass of proton is how much? 1.67 into 10 to the power minus 27 kg. Okay, and speed of alpha particle is of the order of 10 to the power 7 meter per second. So if you substitute that m alpha here and v alpha here, and electronic charge you know, so if you substitute this value, you please check that number, so you will get that expression or the value of distance of closest approach. You will get 10.89 into 10 to the power minus 14 meter. Please check that calculation. Okay, do it at your home. So what that data is given, the speed of alpha particle, initial speed of alpha particle is 10 to the power 7 meter per second. Mass of alpha particle, you know that 4 times mass of proton, and x you have to calculate, that electronic charge is known. Okay, so you can easily calculate. So I have calculated that the distance of closest approach I got, that is 10.89 into 10 की power minus 14 meter. अभी किसी को कोई डाउट है इसमें, इस इक्वेशन में किसी को डाउट है? तो जब क्लोजेस्ट वेरी क्लोज हो गया, जहाँ पे आपका स्पीड 0 हो जाएगा, वहां पे इसका जो काइनेटिक टोटल काइनेटिक एनर्जी अल्फा पार्टिकल का कंप्लीटली कन्वर्टेड टू कूलम्बिक पोटेंशियल एनर्जी, एंड कूलम्बिक पोटेंशियल एनर्जी you know 1/4 pi epsilon naught q1 q2 by r. Okay, so if you substitute that coulombic potential energy, and on the left hand side you have kinetic energy of alpha particle, so if you substitute all this data you will get that number. So you can see that closest approach is of the order of 10 to the power minus 14 meter. It's very close. Okay, so from here he also gave that prediction that the size of nucleus should be less than 15 femtometer. He has not given that exact size, but he said since the distance of closest approach will be larger than the size of nucleus, so the size of nucleus will be less than 15 femtometer. So he has given rough estimation of nucleus size. Is it clear?
Yes, sir.
Sir,
Okay.
can you
हाँ
please explain how did he estimate the size of nucleus?
हाँ, ये देखो आपका जो आपका ये डिस्टेंस ऑफ क्लोजेस्ट अप्रोच कितना मिल रहा है 10.89 into 10 to the power minus 14 मीटर, राइट?
Yes,
अब
sir.
ये तो आपका अल्फा पार्टिकल जब क्या है, ये आपका सेंटर मानो, अल्फा पार्टिकल जब टच नहीं कर रहा है, ये डिस्टेंस है वो, तो साइज जो होगा वो तो उससे भी छोटा होगा ना, कि नहीं?
Yes, sir. Yes,
हाँ,
sir.
yes. So he has given that rough estimation of size of nucleus also, and he said that size of the nucleus will be around or less than 15 femtometer. So you can understand how much significance of Rutherford scattering. Okay. Okay. Now we'll go to that. So you know that mass of proton and mass of neutron is so small, right? Is not it?
Yes, sir.
It is very small. So it that standard unit of measuring mass is what? Kg, right?
Yes, sir. Yes, sir.
But you see that mass of proton and mass of neutron is so small. So it is very it is not significant to measure the mass or nuclear mass in the unit of kg, right? Because when you are writing the mass of proton is how much? 1.67 into 10 to the power minus 27 kg. है ना? जैसे अगर एक छोटा एंट है, उसको 1 kg इसमें नापना चाहते हो, कुछ मिलेगा? कुछ नहीं मिलेगा ना. So we should define some unit to measure that nuclear mass. Okay, so that unit is basically, or you can say unit to measure the nuclear mass is what? Anyone?
Atomic mass.
Atomic mass.
Atomic mass.
Atomic mass unit. Its symbol is U. So what is atomic mass unit? So atomic mass unit means mass of carbon 12. 12 means its mass number. Mass of carbon 12 atom divided by 12. And mass of carbon 12 atom is how much? 1.99 into 10 to the power minus 26 kg divided by 12. So it will be around 1.66 into 10 to the power minus 27 kg. Okay. Shall I erase?
Sir.
Yes.
Clear, sir.
Okay. Okay. So you got this mass, atomic mass in kg unit. Now, many times in exam they will ask you to convert it into mega electron volt. Okay. So how will convert that? You got that on atomic mass, that is 1.66 into 10 to the power minus 27 kg. Okay. So how will convert it into MeV? Shall I erase this part? Shall I erase?
Yes, sir.
Yes, sir.
Okay. So if you multiply 1.66 into 10 to the power minus 27, now if you multiply by c square, okay, divide by c square. Okay. So you see that mc square, that will be the energy unit, right? That will come in joule, right? So what I'm saying, if you write like this 1.66 into 10 to the power minus 27, and now if you substitute that c is how much? 3 into 10 to the power 8 square divided by c square. So that numerator, this will be the energy unit, right? And that will be SI unit, because mass is written in SI, speed is written in SI. Obviously this unit will be joule. Okay. And you know that how to convert from joule to MeV, right? So
Yes, sir.
Yes. Now if you divide by 1.66 into 10 to the power minus 19, This will be, now it will be in electron volt. If you divide by 1.6 into 10 to the power minus 19, and you already have C square. Okay, so unit is converted to electron volt. Now if you calculate this number, you will get around 931.5 mega electron volt per C square.
Sir, after C square, you have multiplied it by electron volt.
Yeah, why? Because I have divided this that number, right? So you know, it's a very 12 class that thing, right? When you are converting from joule to electron volt, so you have to divide by 1.6 into 10 to the power minus 19. So since I have divided, so I should convert that unit from joule to electron volt. And these things is I will deal with the whole nuclear physics. So whenever I'll write, because in exam you that they will provide you that mass in terms of atomic mass unit, and they will ask that answer in terms of MeV per C square. So in whole nuclear physics, I will deal with this number. Okay, is it clear?
Yes, sir.
Okay, good. So now I am interested to write that mass of proton, mass of neutron, and mass of electron in different unit. Then I'll go to that various properties of nucleus. Okay, shall I erase this?
Yes, sir.
Okay. सबको समझ में आ रहा है? किसको समझ में नहीं आ रहा है? आप लोगों को समझ में आ रहा है कि नहीं?
Yes, sir.
Yes, sir.
Yes, sir.
ओके नहीं, अगर किसी को डाउट हो तो वहीं पे पूछ लिया करो, ठीक है ना? You should understand these things. Okay.
Yes, sir.
Okay, so I'll write this mass. So let us write the particle. Okay, or better I will write on it. Particle mass. M means mass. Okay, mass in kg. M means mass. You can write mention in your copy also. Mass in atomic mass unit. Okay, so M, whatever symbol I am using, M means mass. Okay, so U means here atomic mass unit. Then mass in MeV per C square. MeV per C square. So first I will write that mass of proton. How much the mass in kg? It is 1.67, right? 1.6726. 10 to the power minus 27 kg. Mass in atomic mass unit, it will be how much? Okay, so it will be 1.00727 in atomic mass unit, and it is in MeV per C square, it will be 938.28 MeV per C square. Then I will write that mass of neutron. So it will be in kg, it will be 1.650 into 10 to the power minus 27 kg. In atomic mass unit, it will be 1.00866. Okay, and in MeV per C square, it will be 939.5 MeV, 57. Then I'll also write that mass of electron. So it is 9.1 into 10 to the power minus 31 kg. So now if you write it in atomic mass unit, it will be 5.48 into 10 to the power minus 4. And of course, you know this number, rest mass of photon in MeV, it will be 5.1. Okay. So this number actually they will provide, no problem, but it's very important to write this mass in various unit. Okay. Now
This is 10 to the power minus 4.
yes, it's 10 to the power minus 4.
Okay, sir.
Okay. आप लोगों ने लिख लिया?
Yes, sir.
Okay.
Yes, sir.
Now you know that volume, or it is observed that volume of nucleus is proportional to mass number. Volume of nucleus is proportional to mass number. Okay. So since that nucleus is most of the nucleus is spherical, And you know that volume of a sphere, right? It is how much? 4 by 3 pi, how much? R cube, right?
Yes, sir.
And that should be proportional to A. A is what? A is mass number, right? So you can
Yes.
clearly see from this expression that radius of nucleus is proportional to A to A की power 1 by 3. So what you can say that radius is of a nucleus is depends on mass number. Here R is some constant, its value is of the order of femtometer, or you can say 10 to the power minus 15 meter. Okay, so the size of the nucleus will be varied according to mass number. If some nucleus has big mass, its radius will be large. Okay.
So what is R0?
R0 is some constant. Okay, that constant, if you combine that many constants are there, if you combine, you will get these numbers of the order of 10 to the power minus 15 meter.
Yeah, that's under the wood. That's okay.
10 to the power minus 15 meter. Shall I write in upper side?
Yes, sir. Yes, sir.
R0 is of the order of 10 to the power minus 15 in meter. Okay. Okay.
Yes,
Now,
sir.
can anyone calculate that mass density of nucleus? I'm very much interested to calculate that. Can anyone calculate that mass density of nucleus? Shall I erase?
Yes, sir.
Yes, sir.
Yes, sir.
Actually, I'll calculate that mass density and nucleon density. Then I'll proceed for problem, because ultimately we have to do many problems, right? So let us write that mass density first, then we will go to nucleon density, then we will solve a few problems. Okay, interesting problem we'll solve. Now, can anyone calculate that nuclear mass density? Anyone? So mass density, or you can say write nuclear mass density. Nuclear mass density.
Was 45.
Okay, let us check. So mass density means what? Total mass. Total mass will be how much? So suppose you have A is mass number. So if you multiply with proton, so you know each nucleon has mass how much? Mass of proton, because I am considering mass of proton is exactly same as or approximately same as the mass of neutron. So you have number of nucleon is how much? A nucleon is present. So total mass will be how much? A into MP. This is your total mass of nucleus, because each nucleon has MP mass. Here I am considering that mass of proton is same as mass of neutron, and it's obvious we are very small, they are almost close, so I can consider that. So total mass of the nucleus will be how much? A times, since A is the mass number, A times mass of proton. And if you divide by the volume, okay, that will be your mass density, and you know that volume, so it will be A into mass of proton divided by volume is how much? 4 by 3 pi. R is how much? R naught to the power 1 by 3, right? So if you substitute that R cube, it will be R naught cube. A to the power 1 by 3 will be, if you take its cube, it will be A. So that A will be cancelled. And you know that mass of proton is of the order of 10 to the power minus 27 kg. R naught is of the order of 10 to the power minus how much? So if you substitute this,
Sir.
yes.
Sir, 4 by 3 pi r, why you multiplied it with A again in denominator?
Yes, you see that volume you are taking, the nucleus volume, right? The volume will be how much? 4 by 3 pi R cube, right?
Yes,
and
sir.
R is nothing but R naught a to the power 1 by 3. So if you substitute R is how much? R naught a to the power 1 by 3, and it's cube.
Okay, sir. Okay, sir.
Okay. So if you cancel it, you will get 1.67 10 to the power minus 27 divided by 4 by 3 pi, and R naught is of the order of 10 to the power minus 15. 10 to the power minus 15 is cube, right? So if you calculate this order, mass density of nucleus, you will get that order. So it will be 10 to the power minus 45. You have 27. So you will, if you calculate that order, you will get mass density of nucleus will be 10 to the power 17 kg per meter cube. So per meter cube में कितना kg मास है? 10 की power 17. अगर अर्थ का मास डेंसिटी न्यूक्लियस की मास डेंसिटी के बराबर हो जाता, if that mass density of earth is similar to that mass density of nucleus, then earth should be some hundreds of meter, or size of earth should be some hundreds of meter. Do you get that number is so big? Is it clear?
Yes, sir.
Sir,
Yes.
so one point I'm not able. So in numerator A into MP, can you explain it?
Yes. You see, yeah, here itself I'm writing then volume. You see, volume is how much? Nuclear volume is how much? 4/3 pi r cube, right? R is the radius. So
Not denominator. Numerator A into M.
A into MP. So because you have how many nucleons are there? Suppose you have nucleus. So I told you A is the mass number. Mass number means total number of nucleon present. Okay. So each nucleon has mass how much? MP. Okay. And how many nucleons are there? A. So total mass will be how much? So अगर एक न्यूक्लियन का मास कितना है आपका? MP है, क्योंकि यहाँ पे मैं मास ऑफ प्रोटॉन और मास ऑफ न्यूट्रॉन को बराबर मान रहा हूँ, ऑलमोस्ट दैट सेम. सो टोटल नंबर न्यूक्लियन कितना है आपका? अगर एक न्यूक्लियन का मास कितना है? MP है, तो A न्यूक्लियन का मास कितना होगा आपका? सिंपली A into MP, है ना? सिंपल मैथमेटिक्स.
But A is the atomic mass. Why you are considering?
No, you are misunderstanding. A is not atomic mass here. A is the mass number. Mass number means total number of neutron plus total number of proton. A is not atomic mass here, please.
Okay, sir.
Yeah, initially, if you remember, beginning I have defined A is mass number, and that is N plus Z. In today's lecture, at the beginning I told, or I wrote that, right? A is N plus Z is the mass number. Okay?
Sir,
Yes.
सर ये जो न्यूक्लियर मास डेंसिटी है लार्जेस्ट का सिग्निफिकेंस क्या है?
लार्जेस्ट का सिग्निफिकेंस ये है कि वह न्यूक्लियस का साइज बहुत छोटा है और वहां पे आपका बहुत सारे न्यूक्लियंस छोटा साइज में रह रहे हैं ना. यू कैन से नंबर डेंसिटी इज सो लार्ज दैट आल्सो आई विल कैलकुलेट. मास प्रोटॉन का मास तो आपका ज्यादा है. अगर बहुत सारे प्रोटॉन एक साथ रहेंगे छोटे जगह पे तो उसका मास डेंसिटी ज्यादा हो जाएंगे ना, क्योंकि मास डेंसिटी का मतलब क्या है? टोटल मास पर यूनिट वॉल्यूम, मतलब पर यूनिट वॉल्यूम में कितना मास है वही तो मास डेंसिटी है ना. और यू कैन से दैट न्यूक्लियंस आर हाईली पैक्ड. न्यूक्लियंस आर हाईली पैक्ड. इतना छोटा जगह पे आपका बहुत सारे न्यूक्लियन पैक्ड है. इज इट क्लियर?
Yes, sir.
Yes, sir.
नाउ कैन यू कैलकुलेट दैट न्यूक्लियन डेंसिटी?
Yes, sir. Divided by mass.
न्यूक्लियन डेंसिटी हाउ विल बी हाउ मच?
सर ये क्लास में टाइम हो गया है.
हाँ, 1 minute. Nucleon density will be how much?
44 crowd.
So it will be total number of nucleon. How much? Nucleon density means number of nucleon per unit volume. So total number of nucleon you know that is A. Per unit volume means 4/3 pi r naught cube A. So A will be cancelled, and you know that order r naught is of the order of 10 to the power minus 15. Okay, so if you substitute that order, you will get that nucleon density. So now we can also understand that 10 to the power 44 nucleon will be present in per meter cube. You can understand, per meter cube there will be 10 to the power 44 nucleon. Okay, so this is all about your basic properties. Tomorrow we'll discuss few more basic properties: angular momentum, magnetic moment, parity. But before that, tomorrow we'll beginning with some problem. Okay, किसी को कोई डाउट आज के क्लास में?
Sir, how did we get the angular scattering distribution formula?
Okay, that is from classical theory. Atul sir will derive that from central force problem. Okay, because it's a wastage of time. Our goal is to achieve that goal, right? We have to clarify. अगर derive करने जाएंगे फिर उसी में हमारा क्लास खत्म हो जाएगी. Okay, but मेन जो आउटकम है उस फॉर्मूला का मैंने सारे आपको बता दिया कि क्या आउटकम है और how it is so significant. Okay. Okay. So if there is no doubt, then we should stop here. Okay.
Yes, sir. Thank you, sir.
Okay.
Thank
Bye
you,
all.
sir.
Thank you, sir.
Welcome.
Thank you, sir.